Last week, we added the portfolio section to our blog application, and I told you that we would be covering some optional portfolio projects that you can add to your blog. Well, today we're going to be adding the first one of those, which is this procedural generation tool. So you can see here, we just have a link to the actual tool itself, as well as a link to the full portfolio project page for the tool, and it's just an image of what it looks like with a link. Now, if we move over to this link, and then I scroll in a bit, you can see that you have the ability to scroll in and out, and it's just generating some basic noise here that we can scroll through. And then we have some water, some sand for the beaches, some grass, and then some mountains. Now this is a height-based terrain generation, which means you're always going to have mountains surrounded by grass, which is always going to be surrounded by sand, which will always be surrounded by water. You can't have mountains next to water. But this is a good first step for some more sophisticated terrain generation. So I'm going to walk you through what all these things do, and we're going to build something that looks, similar to this type of tool. And you can even see here, if I scale it out, what the noise itself looks like. So basically, we're taking this noise and converting it to this terrain. So this is something that I've done before with the pathfinding visualizer application. This is based on, I think Clements did a video on this, but I added a simplex terrain generator to it, which is totally messed up right now. Let me reset this and make the terrain again. There we go. And you can see that by fine-tuning your noise a little bit, you start to get these nice little patterns for terrain generation. And these are a great way to show that you have like a basic understanding of algorithm design and data structures and stuff like that. So we're going to be going through this, and I do have some helpful examples, but we are going to be doing this inside of P5.js. So if you go to Google and you search for P5.js, you can go to the editor page, and if you log in, you'll be able to save your files. In this case, I'm already logged in, so I'll just save this as the procedural terrain tutorial, and we can start to cover this. So what we have is this neat little terrain generator, which generates this type of terrain. Now, one thing I wanted to cover real quick to sort of give you a better understanding of what this is doing is I have Unreal Engine open over here, which is generating a similar type of terrain, albeit with a little bit of level of detailing right here. So it looks a little bit blurry, but you can see that by applying the same types of strategies that we have here, we're also generating this terrain in an actual game engine, which you could then use to build a game like Minecraft or Terraria. But it's kind of boring to have this 2D noise. So you can use these same types of tricks that we're doing here to move it over to 3D. So this is the actual visual scripting editor that you can use in Unreal Engine. There's no code here. I guess each one of these things you can think of as a function. But the basic idea for this is just to sort of show you at a visual level what's happening. So whenever we have a grid, we of course have an X and a Y, and those are our coordinates right here. We then take that X and that Y and we plug it into a Perlin Noise algorithm. This has a frequency and it has a seed. The frequency, if we mess around with it, just changes how many times we get an occurrence of the thing. So the bigger the number, the more we get. Now you'll see it starts to look like just random speckles. And if we go out far enough, you start to see repeating patterns, which means it's very close to just repeating a complete cycle where there's nothing. But if we take this and we move it to like 0.99, you see a whole bunch of repetitions here, which is creating this interesting pattern, but that really doesn't help us. So the frequency, we're going to have to keep to a low number, like 0.02, actually probably even lower, 0.002, and we can even go down to 0.0002. We then take this number and we multiply it by 100 because this is actually returning -1 to 1. So then we multiply it by 100 to get like -100 to 100, just so it's a bit more manageable for my brain to handle. We have the Z coordinate here, which we then subtract the noise from. This is just for a quirk for Unreal Engine. You don't have to worry about why we're doing this subtraction here. We're just checking if the noise is above or below a certain threshold, but we do it with subtractions to keep it continuous because of how this plugin works. And by doing all of this, we end up with a terrain that looks like this. So there is no height to this terrain. If I come down here to water level, you'll see that it's pretty much a flat surface. But we can very easily change that to, instead of using the Z coordinate right here, which is going into our noise value, we can take this modified version, which is multiplied by 100, which will accentuate what we're doing here. And then if we come back, and then I go down to surface level, we should start to see some small hills. There's nothing super exciting here. If I hit play and my character lands on the ground, you can see that we do have some variation where there's water forming here, but there's nothing super exciting. So what we can do is make it a little bit more exciting by playing with the noise a little bit more. And we can take this out of the Perlin Noise, which is just doing a single instance of the noise generator. We can throw it into the Perlin Fractal, which we can crank up in a minute here, but first I'll just show you this. So if I mess with the frequency again to get it roughly equivalent to what the other one was doing, which is this weird looking pattern right here, and I hit F5, we should get a similar pattern to what we just had with water in random spots. Let me actually enable the water. That'll probably help. So you can see here we have water in some spots where it's lower, and then we have higher spots where there's the hills. If we take this fractal noise here and we increase the number of octaves, so let's say we go up to 2, you see that we start to get more detail. So the first octave is just a really rough pass where it's just this smooth looking shape. And then every time you increase the octaves, you're actually adding a little bit of your amplitude of the noise, which is like how big or how small the noise is. So you're adding like a fraction of the amplitude each time. And you're adding a little bit of the frequency, which means it's occurring a little bit more. So you're just adding little spikes to your noise everywhere. So when you add it, you can see it sort of creates these extra divots. And if we keep increasing this number to say 3 or 4 or 5, you start to get this terrain that looks a lot more like a real world continent would look like, I guess. And if we refresh this, you can see that it does start to change a little bit and creates something more interesting to look at. And if I come down here and I press play, you should see that my character is still being kind of weird, but when you're down at this level, you don't even notice how, like, what the terrain looks like. You just have these hills and the water. So you're really not seeing the bigger picture, which is the overall generation. So even something as simple as this can end up looking pretty interesting if you hook it up correctly. So what I mean by that is we have our noise here being fed into the generator, and then we have some colors over here. And if we come over to the actual plugin here and I tweak it a little bit, you can start to see what happens with the terrain as we add in small amounts of noise and detail everywhere. So the first thing I'm going to do is I'm going to change this from RGB to multi-index, which is going to give us an actual terrain, which is going to use grass instead of that awful blue that we were just using. And this already looks much better than what we had before with the blue and then the water. But we can actually take this a step further. We can switch this to use a stylized type of terrain, which looks a little bit green here. And then we can use some more noise, or the same noise if we wanted to add a procedural foliage spawner. And you can see here that with just a few passes of noise, you start to get a terrain that looks a lot more interesting. Now, one thing that we're seeing here is that it's not really varying up and down too much. So to change that, we can come over here and we can increase what we're multiplying this noise by to, let's say, 150. You can see here now our range is 130 to 135. And if I refresh this, we'll start to get some more elevation changes here and some more hills. And we can actually come up here and we can mess with our frequency a bit. So let's take this and cut it down by 1 order of magnitude. And now you'll see that with that reduction, or I guess that increase in our noise here, we're actually getting a lot more hills. And these hills plus the foliage with no additional computation, all we did was just change that one frequency number, is now giving us, I don't know, something that might be fun to play in. Because if you're the player and you're just messing around in this, and you only see this as your terrain, this already starts to look really interesting with just 2 passes of some noise and no real artwork. I mean, these are all just assets that you can get for free online. So you can see how this sort of adds up. And the reason why I'm explaining this is just so that you get like a better visual understanding of what we're doing when we're coding, because this is a pretty complicated topic to absorb the first time that you're messing with it. So we're going to go through this, and hopefully it'll start to make sense as we go. But I just want you to keep this mental image in mind as we do this, because although we're doing a 2D noise here, we're also using a 2D noise in this generator. We're just interpolating it to the 3rd dimension by doing some basic arithmetic here by multiplying and then subtracting. So just keep that in mind, and then hopefully this project will make a lot more sense. But we're going to start in the editor.p5js.org website, and we're going to create this setup. So the thing to know with P5JS is anything that you write in the left will be previewed in the right. So if we press the play button, you'll see a gray box here because we're drawing a background with a color of 220. So if we change this to 255 and press play, it'll be a white box. And if we change this to 0, it'll be a black box. So the setup runs once and the draw runs every frame. So if we come in here and we do a console.log, and let me actually bump up the font size a bit so you can actually see what I'm doing. Let me leave it at 150. If we do a console.log with the word test, and we have the auto refresh set, or we can just stop this and start this, you'll see test getting console log down here every single frame. If we come into the setup and we do a console.log and we say starting soon, that will only run once. You can see right there it ran once, and then the test continues to run for 200 times. So we need to do our setup logic in here, and we need to do our repetitive logic in here. So the first thing we're going to do in the setup, and if you want to follow along with any of this, like let's say you need to look up how to do something, you can just go to P5JS through Google is what I usually do. I just say frame rate P5JS, and I go to whatever the link is. So here there's a reference page for the frame rate that shows you how to change your FPS. So I want to change mine to frame rate, frame capital R rate. I'm going to change mine to 15, and I'm going to set the pixel density to 1. So the frame rate is pretty self-explanatory. The pixel density we're just setting to 1 because if you're on some weird Retina displays, some of the stuff might not look right. So this is just something that you have to do, or you don't have to do, and you just try your luck and hope the recruiter is not using some kind of like Apple display or whatever. Now, the next thing that we can do is we can set the seed. So P5JS comes with a built-in noise library, which is Perlin Noise, I believe, and that is what we used here. Now, it's important to note that there are many types of noise. There's cellular noise, crater noise, cubic, erosion, Gavaroni, gradient, IQ noise. There's Perlin, there's simplex, which is like a newer version of Perlin, value, Voronoi, and white noise. So, and that's just a selection that's in that plugin. I'm sure there's plenty others like Worley noise. In this case, because we're using Perlin Noise, the reason why you use noise is if we come over to the pathfindout.com website, and I just come over to the random terrain. With random terrain, there's no way for me to know what it's going to do, and there's no way for me to repeat this. If I do a simplex terrain, it is always the same unless I change the seed. So you can see here, I generate it. There's 1, 2, 3 lakes right here. If I click the button again, there's going to be 1, 2, 3 lakes right here. And the reason for that is if we change this seed right here, which is 1337 to 1338, for example, and then we click make terrain, we now have 2 lakes right here. And if we change this again to some other random seed, we have 2 lakes, but they're next to each other. So the terrain changes, but the seed allows us to dictate where it starts. So we can use a random seed to create a random terrain each time, or we can use the same seed to repeat our generation. So in the case of Minecraft, you find people online sharing seeds that are fun to play on. In the case of Terraria, you find certain seeds where the developers made the game harder specifically for that seed. In the case of Photoshop, you might use this, I don't know if it lets you do this, but you might use the same seed to create the same type of clouds that you're seeing in a tutorial, because you can generate layers of clouds in Photoshop. If you have the same seed, you can generate the same exact clouds that you see in the tutorial. So what we can do is we can set the noise seed for P5.js by just calling noise seed and passing in the seed value. So it might be 1337, just like we're using in the Unreal Engine plugin, or it could be 1337, just like we're using in my website whenever you load it up. I'm starting to notice a trend here. I should probably become a little bit more original. But I think we should set it to a seed, and then we can come up to the top here and we'll just say let seed equal 1337. So that's just going to set the procedural seed to whatever we have up here. Now in the, the actual project, you start with a seed of 1337, and you can change it and slide it around, and we'll cover how to do that. But for now, we're just going to use a hard-coded seed, and we're going to play around with it. So we have the seed being created. Now let's set the canvas width and height. Right here, it's set to 400 with a background color of 0. You should be able to see that. I think a better solution would be to set a width equal to 500 and let a height equal 500 as well. And then we can pass in the width and the height. And this is just going to make it a little bit bigger, but the more important factor is we now have these constants up here, which we could even change to capital width and capital height. And then we can put these in here. Because we have these, which we can also change the consts, we can now do some math based on these. So we have our width and the height. Now what I'd like to do is generate something that gets drawn to the screen. So what we can do is in the draw function, we can say for, and we want to go from 0. So we're going to say let's say let y equal 0. And then we'll say y is less than height. Oops, all capitals height. We'll say y plus plus. And then we can do for let x equal 0. X is less than width, x plus plus. Now, I don't know, we could just set all of these colors to some other color maybe, or we can use the noise just to see what it gives us out of the box. So out of the box, we can call a noise function, which will say let noise value equal, and then we'll call noise, where we just pass in x and y. So we now have this x and y. We should probably do something with it. We can set the color here to be that grayscale color that we had in the original application. So if we change this to grayscale, we can mimic something like this. Because the color goes from 0 to 255, like you saw earlier, all we have to do is take this noise, which I should add a comment here. This noise returns a value from 0 to 1. Now, this isn't always the case. In some other cases, like even in this Unreal Engine plugin, the Perlin Noise returns a value from around -1 to 1. So you do have to be careful of that. If it were to return a value from -1 to 1, so let's say if this returned -1 to 1, what you can do is you can take this noise value. So let's say noise value, you can add 1, which is going to take this from 0 to 2. And then you can divide this by 2, which will give you a value from 0 to 1. So that is something to consider if you ever have a noise that returns that kind of range. You can just normalize it like that. In this case, it goes from 0 to 1, so we don't have to worry about that. But we have this 0 to 1. We want to convert this to be from 0 to 255, which of course means that we can just say let noise color equal noise value times 255. So that gets us our color. Now we want to set that. And because we're iterating through this with every Y, with every X, we're setting this color. We need to, I guess, set each one of these. So we're going to have to do some kind of array math here. And P5.js gives us a way to do that. We can actually just call load pixels. And then that lets us come in here and set an array of pixels. So we're going to have to actually set 4 of these, 2, 3, 4. And we're going to need a red, green, blue, and alpha, just like with a regular RGB. I'm going to say let red equal noise color. Let green equal noise color. And then let blue equal noise color. And then we'll say let alpha equal 255 because we just want it to be fully displayed. We can then come into the pixels here and we need to set the pixel value, which is going to involve some other math. We need to create an index because this pixel value is a one-dimensional array and we're using 2 dimensions here. We need to sort of convert. So we'll say let index equal, and we need to do x plus y times the width. So x plus y times the width, which should be all capital width. And we're doing this because we have to go over x spaces, and then we have to go down y times however many spaces are in each y. And then after we do that, we need to multiply this by 4 because we're using 4 array elements, 1 for each of the colors and the alpha. So this gives us our index, which is very confusing. In other cases, you don't have to do this. But we then grab the index and we can say index plus 0 equals red. Index plus 1 equals green. Index plus 2 equals blue. And index plus 3 equals alpha. And once that's done, we come out of this loop at the bottom here. And instead of it saying background 0, which is painting it black, we call update pixels. And if we did that correctly, we should now see this monstrosity. So what's happening here? Well, if you zoom out enough, you end up getting repetition with your noise. So I might even be able to mimic that here. Let me just reset this. And if we come in here and we reduce or we increase the frequency enough, you start to see that exact same pattern. So here we have a frequency of 1. And here we have this a very similar pattern. So you can even see the same type of like horizontal bias where it just wants to keep going over in this direction. So to fix that, we need to do some math with the frequency. What we can do is we can take the frequency and we can multiply it against this x and this y. So we can say multiply x by a frequency and multiply y by a frequency. And if you'll remember, when we did the frequency stuff in Unreal Engine, the more we increase or decrease the frequency, the more we increase it, so the fewer zeros we have, the more it starts to like blow up like this. And if we add more zeros here and we hit enter, it starts to become, I guess, a bit more coherent for us. So here, because we're multiplying it by this frequency, as the number goes down and becomes smaller, we should start to see something similar where we zoom into the noise. So you can see here, we zoom in. If we set this 2.02, And then if we start to zoom in with the scale, you get a very fine grain of what you're looking at. So to do this, let's set a frequency variable up top. This is not going to be a constant, but we can do it right below seed. So say let frequency equal 1. We'll start it off at 1. And now we have this weird looking noise. If we change this to 0.02, we should get something like that. If we change it to 0.02, we get something that looks a bit more recognizable, as I guess recognizable as some random noise, but you get the idea. We now have a frequency which has zoomed in the noise a bit, and it looks a bit more coherent. So how do we do this this slider thing for the frequency so that we can mess around with it? Because that's kind of a cool effect, and it'll probably be impressive for anyone that looks at it that, you know, doesn't understand how this works. Well, in P5.js, we have the ability to create sliders, just like in every other language that has a UI, I guess. But what we'll do here is we'll say, maybe after the create canvas, we'll come over to the end and we'll do a create frequency modifiers. And what we're going to do in here is we're going to create a input for the frequency and a slider. So we'll just do both at once. So let's grab this function name, come down to the bottom here, and then we'll just say function, create frequency modifiers, and then we'll just throw our logic in here. So inside of the frequency modifiers, we need to do a couple things. The first thing is we'll say frequency label equals create div with the label of frequency. And this is just how you can create a div through P5.js or JavaScript or whatever. Again, you can follow along with this. You just need to import a Perlin Noise implementation into your JavaScript application. And then this is going to be virtually the same. You'll just have to replace some of the P5.js specific logic. But it's not terribly hard. You just use a HTML5 canvas instead of these calls to load pixels and update pixels, and you just set the stuff manually. The path find out GitHub page actually has a pretty good illustration of how to do that if you can sort of work your way through what college dean was thinking when he wrote that code. But okay, we have the frequency label showing up right here. We can now set the frequency label position. So we say frequency label dot position, which is going to be equal to 520, 30. But we need to do this because it's a function. I don't know what I'm doing. So we'll say width plus 20, 30. So if we do that, it'll move it over here. And if we leave this at 0, it should put it at the top right there. It looks good to me. Now we can set the frequency slider, which means we have to create it. So let's come up here, and I guess below the width and the height, let's do a let frequency slider, and then we'll say let frequency input. So we'll just create two variables, one for each. So the frequency slider here is going to be equal to create slider. And because the frequency is such a weird variable, we need to make sure that it goes from the right range. So we're going to go from 0.001 to 1. Frequency is going to be the default value. So this is the minimum to the maximum with the default value set to whatever we set it up here, 0.02. And then we can declare a step size, which is just how much it'll go every time you move it over one. And our step size here is just going to be whatever the minimum value is, so 0.01 or 0.001. And now if we slide this, we're changing the frequency. It's just nothing else is happening. So the next thing we want to do is set the parent of this frequency slider. So say frequency slider dot parent. And we'll set this equal to the frequency label, which is that div we created earlier. which will move it over to the side here, right next to our frequency text. So now it's a little bit more organized, which of course begs the question, what happens if we have multiple of these? So if we have like a seed here, then our slider will start right next to it. So we want to set a position for the frequency slider dot position, and we want to set this relative to everything else in the parent div. Oops. So we'll set it to 250, which will move it off screen a little bit. Let me move this over. So the reason why we set this to 250 is because we're actually going to put the input first, or, you know, I think we'll put the slider first. So let's set this to 100. So 100 will put it right there, and then we'll put the input below it. So the input is pretty similar to what we just did here. I guess we should probably do this too. We should say frequency slider dot input is going to be equal to a function that we call whenever we change the input here. So we're going to say this is the frequency input event is what we're going to call this function. And then we'll just create that real quick. And I'm going to move this down a bit so we can see more. So we'll say function frequency input event. Doesn't take any arguments, but it will just do some basic logic for us where it sets the values. So we'll set the frequency equal to, and it's just going to be this dot value. Thankfully, we can call it like that. And then we'll set the frequency slider dot value to be equal to this dot value. And then we can also set the input in a minute here, but this will at least let us slide the noise up and down and give us that cool zooming effect. So now let's do an input so we can actually type in a number and see what the number is. For this, we'll say the frequency input, which we probably have to declare. Oh, wait, we already did. Cool. So the frequency input needs to have a, well, it needs to be created. So we'll say create input, and we'll give it a value of frequency.toString. And that'll give us the 0.02 down here. Now we want to move it up to where the frequency is. So you know what that means. We need to say frequency input dot parent is equal to frequency label, just like we did with the slider up here. So that, oops, that moves the input up top, and it should be right on top of the slider. So now let's say the frequency input dot position should be 250 by 0. So now it's moved over to the side here. And the last thing we can do is we can say frequency input dot input, which is going to be that same on event listener we have up there, is going to be the frequency input event. And the reason why we're using the same event for each of these is because if we change one, we want to change the frequency, and then we also want to change the other. So this also now needs to change the frequency input to have a dot value of this dot value. So if we do that and we get the preview back, if we move this over, you can now see that this is changing our value over here. And if I come over here and I say I want it to be 0.001, it changes it. I can get rid of one of these and it backs it out. Okay, so that is one entire input event handled. So we also have the seed. So let's see how we can replicate this for the seed. So we're going to need a slider and an input. So let's actually move this above the frequency slider just to keep things a bit more organized. I'm going to copy the word seed because we're going to be using it a bit here. So that gives us a seed and a slider. We then come down here and we need to create seed modifiers, which is just going to create our slider and our input. We can then come down here and say function create seed modifiers. You can then grab everything inside of this create frequency modifiers, paste it in here, come up to the start, hit Control F, search for the word frequency, click the little arrow, replace it with the word seed. So So let me just find one of these. Okay, so now we're on the first frequency. I'm going to click replace, and I'm just going to go down and replace all of these with the word seed. And I'm going to stop at line 56 to make sure that I don't replace any of the actual frequencies. So this first one didn't get replaced. I'm going to hit seed there, and I'm going to close out of this find and replace. We're now going to grab the frequency input here, and right above it, I'll paste in the, just had a mosquito land on me. I'll paste in the seed input event, and I'll replace this manually. So we need a seed here, and a seed here. And now we need to figure out how we're going to do the layout here. So we have the seed right here being set at a position of width plus 20. Let's set the frequency modifiers to have a position of, oops, not width plus 20, of, I don't know, 30. So we'll just make it go down by 30 each time. And we should probably capitalize the S in seed. So that now gives us a seed, but you can see here that the slider is a little bit off because this needs to actually go from like, I don't know, let's say it needs to go from 1 to 1 million maybe. I don't know, some ridiculously big number, and we want the slider step size to be 1. So now if we use the arrow keys, you can see it goes up and down by 1, or we can just set this to like 500,000. So the seed isn't changing right now. So if we like change the seed to like 13, it's not changing the actual noise. And the reason for that is the noise seed is actually being set in the setup, and then it's not being set again. So we need to change how this is being set. So the way we can do this is we can grab the logic here in the draw method, and we can just create all of this in a separate method. So let's do the load pixels and the update pixels, and let's change this to just be a function that's called generate terrain. Let's come down to the bottom here and create a function called generate terrain. And then let's paste in our terrain generation just to make sure that's all there. So we have the load pixels. Now above that, what I want to do is just say the noise seed should be the seed. And now if we scrub through this, you can see we get a random seed each time, except it's not really random. It's just whatever this is set to. So if I want to go back, I can just set it to 1337 again. So one thing we should probably do is we should make sure that we're not redrawing all of this logic every frame, because this is starting to get a little bit laggy. So the way we can do this is by creating some cached variables and just checking if our current values are different from our previous values. That way we don't keep doing this draw call every single time. So we can just say let cached seed equal 0, let cached frequency equal 0. And then in our draw call, instead of doing a generate terrain, we can just do if cached seed does not equal seed. That means our seed is different from the last time we were here. Or cached frequency does not equal frequency. Then we want to do a call to generate the terrain, which we'll just paste right there. So now you should already notice that your editor is much more responsive, and we can scrub through this a lot faster because it's not doing a different draw call every single time. So if we come down to generate terrain, we now need to make sure that if we come in here, we update this. So let's say the cached frequency should now be equal to the frequency, and the cached seed should now be equal to the seed. And this should improve the performance a little bit as well. If I scrub through this, it's now really snappy because it doesn't need to do all those extra computations every single time. So that handles the frequency and the seed. Now, if we come back over here, you'll see we have a couple other options. We have the scale, the amplitude, octaves, persistence, and lacunarity. So what we're going to do for now is we're going to focus on the scale and the amplitude, and then we're going to do these three sort of at the same time. We also have the ability to toggle between the GreyScale and the water, but that might be a little bit more interesting after we have more than just the basic noise happening. So let's start with scale and amplitude, just because we've already gone through these a few times. So let's come up to the top, repeat what we did. We have a frequency. We'll say let scale equal 1. Let amplitude equal 1. But I think scale is actually a key value in P5.js. So I'm going to change this to scale value, or it's like a keyword because it's highlighted a little bit weird. So we can do that. And then we can create the inputs and the sliders for those two. So let's come down here and change these. So let's grab the scale value. We'll create the scale value slider and the scale value input. We'll grab the amplitude. We'll create the amplitude slider and the amplitude input. We'll then grab the frequency modifiers, paste this twice. We'll replace the first one with the scale value modifiers and the second one with the amplitude modifiers. Okay, now that we have that, we need to do a check to make sure that our cached variables are updating. So let's come up to the top. Let's create a cached scale value equals 0 and a cached amplitude equals 0. And then in our draw call, we just say or cached scale value does not equal scale value, or cached amplitude does not equal amplitude. And then we can come down here and we can create the slider and the input for these. So we'll grab this one, we'll paste it down here. We'll grab another one, paste it down here. The first one is going to be the scale value modifiers. So we're going to just do a Control F for frequency. And then we're going to do a replace as soon as we find the first one of these. So we'll come down a bit to the scale value modifiers. I don't know why it's starting me in a weird place. We'll replace frequency with the word scale. Actually, we'll replace it with the word scale value just to be consistent. And then we'll just click replace, 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 replace all the way down until we're at the end of this method. And then we'll come up here and we'll replace this one with a scale value label. And we'll replace the div text with just the word scale. Now this should be 60 instead of 30, just to bump it down. And now we can come down to the frequency and we can replace this with the amplitude. We'll just say amplitude modifiers, and then we'll just search for this. So this should give us the first frequency here, and then we'll just replace this with the word amplitude. Replace, replace, replace all the way down. And then we want to come back up here and replace this first amplitude label. Oops, amplitude label, and then replace the text. And then this should now be 60 plus 30 is 90 down. And now it's throwing an error because we need the scale input value and the amplitude input value. So let's do those. So we'll grab the frequency input event. We'll paste two of these. First one will be the scale value input event, which will then replace for this one, and this one. And then the next one is going to be the amplitude input event. And we'll replace this one, and this one. And after all that copy pasta, we now need to change our step size here and the rest of our values. But if we change these, nothing will happen. So let's start with the step size here. For the scale, I think a good value would be a 1 for the minimum, a 100 for the maximum with a step size of 1. And then for the amplitude, we'll start at 1. We'll go up to, I don't know, this one doesn't need to be that big, right? We'll just set it to 100. I don't think you're going to go higher than like 15 maybe, but we'll give it a step size of 1 as well. So that handles the slidey boy and the input, but now we need to change the actual noise when we use those. So for that, we need to come down to the bottom again. I'm going to click stop real quick. But once we're down here, we need to sort of mess with the math a little bit. So the amplitude is just going to be something that multiplies all of this noise. So we'll say this times amplitude will handle that. And now if I press play and I change the amplitude, you can see that it very quickly just gets overpowered by the white, which is very similar to what happens here. If I come over to the pathfinding visualizer, I actually inverted the colors. But if I sort of change the threshold a bit, you can see what happens. Instead of it getting overpowered by white, it gets overpowered by black until eventually there's nothing left. It's very similar to what's happening here. If the amplitude gets too big, everything just turns white. So the reason why that happens is because we're multiplying the noise value by 255. And as the amplitude increases to like 10, so let's say we set this to 10, the reason why there's only a little bit of noise, if we can even see it, really small amounts, is because by multiplying by 10, this value is no longer going from 0 to 255. It's now going from like 0 to 10, and then 10 is 100, and then 100 is like 1,000, and everything past 255 is just pure white. So you have like 60% of the numbers are already just pure white, and then the rest are really close to white because of the multiplication. So amplitude is really powerful here, and it's not really something that should be set super high because it just completely blows out everything else. We're going to leave it in though, because it's important to learn what it does. Now the scale is a different story. So the scale value is just something that's going to wrap around the X and Y coordinates. So it's going to be X divided by the scale, and then it's going to be Y divided by the scale, except it needs to be scale value. You can see here using the word scale, it gets bolded just like noise does. So I think it's like a function or something. But by dividing X and Y by that value, and then multiplying by the frequency, like we're doing here, so we have a set of parentheses here, a set of parentheses here, we have a set of parentheses here, and then a set of parentheses here. This now gives us a proper setup, I think, right? So 2 around this and 2 around this. Yeah, so that seems right. Now, if we move the scale, we zoom in and we zoom out. But we zoom in and zoom out a little bit different to what frequency does. But you can see here that it's sort of similar in how they operate, which makes sense because it's just frequency times this, and this is just dividing it. But sometimes you'll see people refer to it as scale. Sometimes you'll see them refer to it as frequency, and having both of the sliders, at least to me, it helps me figure out what each one does, and it makes it a bit more intuitive when people talk about it. So we have our scale, we have our frequency. Let's go ahead and move on. Now at this point, we effectively have the system that we had earlier with the basic Perlin noise. The only thing we don't have is the fractals that add all the extra detail. So remember, if we set this to 1, it creates those really weird shapes that are just super smooth. So we want to like have this at 5 so that we do 5 iterations of the noise so that things are a bit more detailed. The way we did that over here is with a set of octaves. And if the octaves are bigger than 1, then persistence and lacunarity start to kick in, and it starts to change how the noise looks. So if I toggle off the grayscale here and I move the persistence up, you can see it starts to like absorb the world, because this is just changing your values a little bit. So the lacunarity affects the fall off of your frequency, I think, and the persistence affects the fall off of your amplitude. So each octave you have less and less frequency and amplitude, which is what these two are affecting. So your persistence here is going to change your amplitude, which is why if the persistence goes up, all the values start to skyrocket, and that's why everything gets taken over by the mountains. And if the lacunarity goes up or down, you don't see as much change here because it's just messing with the number of times the frequency happens, which gives you more rugged edges here. So you can see here it's a smooth edge. 1, 2, 3, 4, 5, 6, all the way up to 10. You start to get more realistic terrains here with 10 on your lacunarity, because it's giving you slightly more frequency each time, although it's a diminishing amount each time. So that is how we're doing the fine details. but I think it would help if we were to refactor this a bit to give us the colors now, because I think the colors around here are where they start to become helpful. So to do that, we're going to add a checkbox to check between grayscale and color. So we'll go up to the top. I need to find the code for reference over here. And then we can create the checkbox. So we're going to say let, and I'm actually just going to copy both of these over here. I'm going to say let grayscale checkbox and let use grayscale equal false so that it defaults to color. So if I come over here and refresh, it's color by default. So that's why we're setting let grayscale equal false. We can then come down, because you already know the drill by now, hopefully. We need to call a function inside of setup at the bottom here that says create the grayscale checkbox. We then need to check if this has changed, because if this has changed, we need to do a draw call to either draw the colors or draw the black and white. So we'll say cached grayscale does not equal grayscale, except this needs to be use grayscale. So let's come up to the top and let's create this cached value. Let cached grayscale equal false. Now let's go down to where we actually need to use this. So below the input events here, we're going to create the checkbox. Now creating the checkbox is actually pretty easy. We're going to say function create grayscale checkbox. It's actually only 2 lines. So grayscale checkbox, grayscale checkbox is equal to create checkbox. The first one is the text, so say use checkbox question mark. And the second one is the default value for the checkbox, so we'll say use grayscale. So the default value here, if I set this to true, you'll see our checkbox down here. If I set it to true and it refreshes, it's just checked. So because it's false by default in our variable here, that's why it's not checked. But the checkbox works. We can check it and uncheck it. It just doesn't actually do anything yet. So we have that. Now we need to set a onChanged. So we'll say grayscale checkbox dot changed needs to call a function called grayscale checkbox event. I'm actually going to copy this and then come down here. I'll say function grayscale checkbox event. And in here, we need to say use grayscale equals grayscale checkbox dot checked. And that is all we have to do for the checkbox to actually do stuff. Now we need it to affect stuff. And the way we get it to affect stuff is to come into our generate terrain. We need to say this has a cached, actually we forgot to do the cached scale. So say cached scale value equals scale value. And then we need to do cached amplitude equals amplitude. This explains why it was getting a little bit laggy. And now hopefully it's, oh my God, it's already a lot better. Let's do a cached grayscale. What did I call it? Cached grayscale equals use grayscale. There we go. And now what we need to do is this inner part where we do the painting of the pixels and the index. This right here, I believe, can all leave. And instead, what we'll do is we'll call a function called paint terrain, which will take in a noise value and it'll take in a index. So that works. We can then come down here and we'll say function paint terrain, which takes in a noise value and a index, does this. Now index here has already been defined, so let's get rid of this let. And then we need to return our pixels. So say return pixels. And then our paint terrain needs to be pixels equal to paint terrain. And our index here, I messed up, actually is being defined up top. So we pass in the index like that, it goes into the function, and then we just use it. So now we're back to having this gray stuff, but now we want to do a check to see if we are using grayscale or not. So at the top here, I'm just going to say let noise color red, green, blue, and alpha. So I'm just defining all of those at the start, and then I'm going to get rid of all these lets, and then I'm actually going to tab everything over because it looks really ugly right now. And then I'm just going to do a check to see if we should use the grayscale. So, oops, if we should use the grayscale, then we want to do all this color nonsense. So we'll just tab this over, tab this back, and then backspace. Otherwise, we are doing color stuff, in which case we need to do a calculation. So we'll say result is equal to get terrain tile, just because I didn't know what to call it. And then we'll pass in our noise value. So now we need to create this function. We'll come down here. We'll say function get terrain tile for the noise value. And then let's hit enter a few times to move this down. So our logic here is going to be, we have a value. We have a value between 0 and 1. If it's close to 0, make it water. The closer to 1 it gets, the higher it should be, right? So we'll say if the noise value is greater than 0 and the noise value is less than or equal to 25, or sorry, 0.25, then we need to return a color. So we'll say return watercolor. And we don't have a watercolor defined yet, but we'll worry about that in a second. Else if the noise value is greater than 0.25 and the noise value is less than or equal to 0.5, then let's return a sand color. Else if the noise value is greater than 0.5 and the noise value is less than or equal to 0.75, we want to return the grass color. And then we'll say else it's bigger than 0.75, so let's just return a mountain color. So we don't have any of these colors defined. Let's go up to the top and let's actually define these. The way that this is going to work, because we have 4 things in our pixels that we're setting, we're going to need to return an array with 4 values. So it's going to have to be an array with the first value being the red, the second the green, the third the blue, the fourth the alpha. And the way that I found these values is I just go to Google. I go to Google and I search for, first one's water. So I said water color RGB. And I went to whatever the result was. So we have color hex, which has some colors, and you just grab one of these. It has the RGB right here. So 1594156. So right here, let's say let water color equal an array that has those numbers in it. And then at the end, we'll say 255 for the alpha. And then we can do the next one. So we'll say let sand color equal an array where the last element is 255. And let's come back over to Google, or I guess color hex, sure. And let's search for sand color. Didn't like that. Let's just search for the word sand. Okay, let's just go to Google. Let's search for the word sand color RGB here. And we have a color hexa result, which looks sandy. Sure, why not? This is 76, 70, and 50. So say 76, 70, and 50. And then we'll just do another one for the grass color, which is going to be equal to grass. Okay, let's go back to Google. Grass color RGB. I don't know why all these websites are so hard to use when it comes to searching for colors. We'll grab this one if we have a RGB somewhere. Right here, 86, 125, 70. So we'll say 86, 125, 70, 255. And then let mountain color equal something. I'm going to go back to Google. I'm not even going to try. I'm going to say mountain color RGB. And let's see what they got. I don't know why green is showing up. UFO green. That's a little bit strange. This seems like a good mountain color. 129, 139, 153. So we'll say 129, 139, 153, 255. And now we can scroll down to here. Because we're using this function, but we're not actually doing anything. The other thing that I want to do is change this checkbox real quick because it says use checkbox, which is kind of weird. Let's change this to use GreyScale, ? There we go. And then down here, we need to get the result of the terrain tile, which we have. And we need to break this up. So we'll say the red should be result 0. The green should be equal to result 1. And of course, there's other ways to do this. But this feels a bit more explicit right now. And I feel like there's already enough to digest here. But we can do the alpha as a result of 3. And by doing that, we now have a terrain. Now, of course, the colors are different than over here, which is just because I used different colors. But one thing you'll notice is that our water is a very small minority here. It's actually looking like it's about 25%, which is because we have it set to a 25 threshold over here. In my actual code, I cranked up this value quite a bit to 0.5. The sand color I had set to 0.5 and 0.55, which gives you that little bit of a border. That's also a really, really ugly sand color. And then this mountain was 0.55 to 0.75 for the grass. Sorry, not for the mountain. And then everything after that was the mountain color. So this sand, I don't think I copied correctly. So sand, 76, 70, 50. Let's see, where was the sand? Okay, let's just look for a different sand color. What do we got? Any of these look good? I'm just going to grab the sand color that I got earlier because I like that one quite a bit. So you can follow along with that. I'll scroll up to the top here. Sand. It was 194, 178, 128, 255. And that gives us this nice sand color around our islands. And now you can see we have these islands looking a bit more like islands instead of just being things with little lakes. But maybe you like the lakes, in which case, you know, keep the thresholds a bit more tight around the oceans. The lower the ocean value is, the less ocean you get, basically. But okay, let's add in our remaining options here. One was to scroll to zoom, and the other one was the octaves, persistence, and the lacunarity. So let's go up a little bit to the top, and let's just add in the scroll slider real quick so that we can deal with the other options. So the scroll checkbox, which I'm just going to copy over, is very similar to the GreyScale checkbox. So we just add these two lines right here. We don't need a cached scroll because it's not going to be drawing anything to the screen. But we do need to create the scroll scale checkbox, which we're going to call the function right there. And basically what happens here is we console.log the event.delta. If we do that, come over here and scroll up, it'll give you a -100. And if we scroll down, it'll give you a +100. So what I did here, which is a little bit hacky, but it works for the demo, is I said, let the scroll step equal the event.delta divided by -100. Because scrolling up was giving a negative number, now it'll give a positive number, which will increase our scale. And scrolling down was giving a positive number, but now it'll give a negative number, which will decrease our scale. You can, of course, change this. It's just, to me, scrolling up and increasing the scale makes the most sense. But we have the scroll step. I then said, let's set the scale value to be, and there is no clamp function, so I had to use constrain. So I used basically the same thing as a clamp function, and then I set the scale value plus the scroll step to be clamped between a minimum of 1 and a maximum of 100. Now, the issue with this is, of course, I didn't like that you were always forced to increase the scale if you zoomed in, because that could be a little bit annoying for user experience. So I just added this checkbox for it. So basically what we do is at the start here, we just say, if we are not supposed to scroll effect scale, then let's return. So we need to set the scroll effect scale if we click on the checkbox, which we can do real quick if I find it over here. So we just need to go down to the checkbox, wherever that was, right here. And we'll just create a function very similar to this one. Let me move this over so you can read this. Basically, we create a function with the checkbox set to create a checkbox that asks, do you want to scroll to zoom? If you do, then the scroll effect scale variable will be set. And then if this checkbox is changed, we then call the scroll scale checkbox event, which you can already guess what that does based on the GreyScale. We just replace the variable names and we call .checked. So now if the scroll to zoom is checked and I scroll up, oops, and it looks like the scroll effect scale is not a variable. So what we probably have to do is grab the, we'll just grab this. We want to find the scroll effect scale, which is on line 64. And we want to replace this because I was missing an S. So now if I scroll in, we don't have the set scale function defined. So let's create that real quick. Below mouse wheel, we'll create a new function, call this set scale value, which will take in a new value. And then we'll say scale value is equal to new value. Scale input dot value is equal to the new value. And then scale slider dot value is equal to the new value as well, which will update our numbers in our slider over here. So now if I scroll in, the scale input is not defined, which means I probably named it something else up here. Scale value input, of course. So let's change this. Now, if we scroll in, we get the same issue here with the scale value slider. And now if we scroll in, now it's working. So now you can scroll all the way in if you want to, or scroll out to 1. So that's just a nice quality of life. And if I uncheck this, it doesn't do anything, even though I'm scrolling. So, okay, that takes care of that. Now let's deal with the Lacunarity, persistence, and the octaves. So for these, we're going to create similar variables. We're going to create a variable for octaves, persistence, and Lacunarity. I'm going to set octaves to default to 1, persistence to 0.1, and Lacunarity to 6. Okay, now let's create the sliders and the input for these. So I'm going to copy the amplitude and do 1, 2, 3. I'm going to hit an enter after each one of these. First one will be the octaves slider. And then I'll just copy this, come down here and paste it in. And the last one will be the Lacunarity slider and the input. So that takes care of those 3. We now need a cached value for each of them. So let's grab the cached amplitude here just to keep things organized. 1, 2, 3. First one will be the cached octaves. Second one will be the cached persistence, and the last one will be the cached Lacunarity. We then come down here and create the octaves modifiers. We'll just copy this. Next one will be the create persistence modifiers, and then we need the create Lacunarity modifiers. And now we need to create all 3 of these, which means coming down here below the rest of these, we'll grab the amplitude, say 1, 2, 3. And then for the first one here, it will be the octaves modifiers. We'll do a Control F for the word amplitude. We'll just highlight this, do next, next. There we go. We're going to come down to the octaves modifiers down here, and then we want to replace the amplitudes with octaves. Say replace, replace, replace. I don't know why it doesn't like replacing the first one, but whatever. Let's come right here. Let's replace this one with the persistence. We're just going to go down and then we'll fix that one that's missing. Persistence, and then this needs to be a lowercase p persistence, and then we'll just do a replace for all of these. Replace, next, and finally it will be the Lacunarity. We'll say replace all the way down as well. except, oops, that was not right. We want to come down to here. This needs to be Lacunarity without the capital letter. There we go. So we can do that. And apparently it missed some, but that's fine. So let's come up here to the Lacunarity and let's just replace these. Lacunarity slider, 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 label, Lacunarity, and then this should be Lacunarity, oops, Lacunarity. And then this is the Lacunarity label. We can come up to the persistence, do a capital P on this persistence. Rest of it's fine. And then we can come over to here, and this is the octaves label with a capital O for octaves. And now we need to change the horizontal or the vertical spacing here. So for the, oops, let me just close this. For the last one, it was 90, it looks like. So let's do 120. We'll do 150. And then we'll do 180 for this one. Now it's not going to go past the octaves here for visible because we need to create the input events for those. So let's do that real quick. We come to the amplitude. We'll do copy paste 1, 2, 3. First one will be octaves. And then let me move my mouse. We'll get rid of this one with octaves. We'll get rid of this one with octaves and this one. And now our persistence shows up. So we'll do the same thing. Persistence. We'll come down one. Let me click off because for some reason this Google Translate thing is in the way. We'll do that persistence, that persistence, that persistence. And then the last one here will be the Lacunarity. And then we can replace this one, and this one. Okay, so that handles all of our sliders and all that other nonsense, but we need to give these some better values than just 1 to 100. So let's come up to the octaves one. The octaves I had set to a number between 1 and 5 with a step size of 1. Persistence I had set to a value of 0 and 1 with a step size of 0.01. And Lacunarity I had set to a value between 0 and 10 with a step size of 1. So now if we scroll through these, we can see the proper numbers showing up. So let's come down here to the generate terrain. And actually, now that I'm thinking about it, let's come up to the function here because we have the GreyScale. Let's do or cached octaves does not equal octaves, or cached persistence does not equal persistence, or then we'll say the cached Lacunarity does not equal Lacunarity. Move this over one. That takes care of our caching right there. Now we need to come down to the bottom and we need to say cached octaves equals octaves, cached cached persistence equals persistence, and cached Lacunarity equals Lacunarity. So that takes care of all of the caching. So now I can stop lagging again. And then in here, what we need to do is we need to do another loop for the octaves, and we need to keep a running total. So we're going to come right here and we're going to say for let octave iterator, or we can even just say let octave equal 0. Octave is less than the number of octaves. Octave plus plus. We can backspace this, come down here and do this. Actually, let's move this outside of the index. Doesn't make sense to do it in the index. So that takes care of the, I guess the positioning of that, but above the octaves, we need to create a couple variables. So we're going to say let the total equal 0. Let the octave frequency equal frequency. And let the octave amplitude equal the amplitude. And this is just because we're going to be modifying the frequency and the amplitude with the lacunarity and the persistence. So I don't want to modify the actual values. Otherwise, these will change every time we do something. So what that means is we have to grab the octave frequency and replace this frequency and this frequency. And then we have to grab the octave amplitude and replace this amplitude. And then what we want to do after we've done that is come down here. We'll say total should plus equal the noise value, which means instead of painting this with the noise value, we want to paint this with the total. We want the octave frequency to be times equal to the lacunarity. And we want the octave amplitude to be times equal the persistence, which should give us what we want right here. And let's just test that. Let's increase the octaves to 2, increase the persistence. That's giving us our super grainy results there like we expect. And then octaves, if we go down, causes the terrain to have like fewer details. And then as it goes up, it starts to get more and more grainy, which is about what we would expect. If I move this up to 2, you can see here, this is doing a similar thing. If I come over to the pathfinding visualizer and I increase the lacunarity, it adds all that grainy detail. If I increase the persistence, it causes it to spread everywhere. So this is now doing the same thing that that little terrain generator is doing. And if we apply these same principles over to the Unreal Engine, you can see that the results are a very interesting terrain with some pretty cool features. I mean, this is just one set of noise. You can imagine what happens if you combine multiple sets. So if you had like a like maybe 4 or 5 different noises that you add together, if this will load, you can actually end up with some pretty complicated logic that mimics sort of like a real world terrain without much math involved, because you're just using the same principles as what you just did with the Perlin noise. So in this case, if I get rid of the ocean, if I hide the ocean, you can see here we have these little patches of land, and then we have these giant ravines that are under the ocean, which gives us the ocean floor, similar to like the trenches you would find in the ocean. But it's all covered by the water because there's only small amounts of land that you can see, which is the exact opposite of what we just did over in the other one, where we had a lot of land with some water nearby. And again, that's just by doing similar stuff with a combination of colors here, where we're checking if it's greater than or equal to 50, 55, and 75. It's the same thing we're doing over here, where we're checking if it's greater than or equal to 0.5, 0.55, and 0.75. So hopefully you learned something by doing this. Now for the actual point of this, which is the Rails tutorial, which is actually pretty funny, but what I'm going to do is I'm going to stop the server. I'm going to bump up the font size a bit, and I actually need to do a git checkout main. I need to do a git checkout -b. I don't actually know what branch I'm supposed to be on, so let's do a git branch just to see what the latest branch is. It is branch 20, apparently. So let's do a git checkout -b episode _20. And then we'll say Rails S to start the server. Excuse me. And then I can come over to, I don't have it open anymore, but let's just open it in a new tab. Say localhost port 3000. Let me full screen this. We'll come over to the new project. We'll give this a title, Procedural Terrain Generator. We need a link. So for that, we'll come over to the actual project. I'm going to hit Control S to save this. File, download. I'm going to download it to my downloads folder. I'm going to call this, I don't know, Procedural Terrain Tutorial. That gives us a zip file. So we'll come over to the downloads folder here, grab this one and extract it. Okay, once that's extracted, we'll come over to the folder. I'm going to cd out of here and go into Procedural Terrain Generate or Tutorial, whatever. Now I'm going to do a, let me bump up the font size. I'm going to do a git init, git add dot, git commit dash m, init commit. Okay, so that gives us the project in a GitHub or in a Git repository. Now we're going to come over to GitHub. We're going to create a new repo. We'll call this the procedural underscore terrain underscore generator underscore video. We'll leave it public and we'll create the repository. I'm going to click on SSH and I'm going to click the copy right here to push up an existing repository. I'm going to right click in my terminal, paste anyways, then I'm going to enter on the push to origin main. I'll now refresh the page and the code should be up here. If I open up the index.html, you can see it has a p5.js import with a sound and then the sketch. And if we back out and go into sketch.js, that is where all of our logic is that we just wrote. But if we come over to settings and we look for pages, we click on pages, we can then select a source, which will be the main branch, click save. We'll grab this link, we'll come back to the repository main page, and we'll add about info. We'll give a short description, procedural terrain generator in p5.js. We'll paste in the website URL. We'll give it some tags, JavaScript, p5.js, and I don't know, procedural programming, procedural terrain. Sure. We'll click Save Changes. Now, if we click on this link, GitHub should be getting this up and running, but it looks like it's not quite there yet. So let's come back over to the pages page. It says it's ready to be published, but it doesn't look like it is quite yet. So let's check in another browser. Let me open up Chrome. There we go. I've opened up Chrome. Here is our procedural terrain generator. Looks like this one's cached to a dead link, but this is what it looks like right now. So what I like to do here is refresh, grab it in whatever the default view is, and then I just highlight, grab a screenshot with Windows key, Shift and S if you're on Windows. And then come back over to our, wherever the localhost project is. We'll paste in the image. So there's our image. We'll grab the link to the project. And if I refresh now, it's working in Brave, so that's good too. We'll put the link in right here, and then we'll just give this a description. And for this, I don't know, I'll just say procedural terrain generator that utilizes Perlin Noise to create complex terrain patterns. Something like that. And then I put a semicolon there because I've been programming too much. We can also say maybe like the source code is available on GitHub. We'll grab this, we'll convert this to a link. And we can grab a link to the GitHub repo. We'll paste this in, click link. And then we can say the project is also available here. And then we'll grab the link, we'll copy or we'll highlight the here, click the link button, paste in the link, do the link. And then right here, we'll add a caption where we'll say procedural Perlin Noise Terrain Generation Overview or something. Then we'll create the project. You can now see we have the project over on the projects page. We can come over to the portfolio page where we get an error from Bullet telling us that we need to eager load better, which we can deal in a different tutorial. We're already way past the time budget for this. But now you can see we have the path find out project right here, and we have the procedural terrain generator project posted twice. This was the one I did earlier because I'm using the same database, but you get the idea. So this is the one we just created. And it looks actually exactly identical to the last one we made because we're using the same seed. Oh man. So yeah, that's going to do it for this video. Hopefully you learned something. Hopefully this was helpful. And I will see you in the next tutorial where we hopefully cover some more of this procedural terrain generation stuff, either next Wednesday or Tuesday or Thursday. I don't know yet, but we'll see sometime next week. But that's going to do it for now. Thank you so much for watching, and I'll see you in the next video.